Okay, this is an interesting problem from Jee Advanced Physics. Okay, so the problem is given they consider a spherical gaseous cloud of mass density rho in free space where r is the radial distance from its center. So this is like this spherical gaseous cloud. This is this. So this is rho r gaseous cloud of mass density rho r in free space where r is the radial distance from its center. This is r. And the gaseous cloud is made of particles of equal mass m. Gaseous cloud is made of particles equal mass m moving in a circular orbit around the common center with same kinetic energy k. Okay. So gaseous cloud is made of particles which mass m moving in a circular orbit in the common center about its common center with same kinetic energy k. So k is equal to mv square by 2. Okay. And the force acting on the particle is their mutual gravitational force, and if rho r is constant in time, the particles number density I have to find out among which option is correct. Okay. So gaseous cloud is made of particles of equal mass m moving in a circular orbits about the common center is same kinetic energy. So k is equal to m square by 2. And the force acting on the particle is a mutual gravitational force. So for any particles of mass m, this gravitational force is balanced by their centrifugal force or centrifugal force. Okay, gravitational force is balanced by centrifugal force, not centrifugal, it is centrifugal force. So balanced condition. Okay, so G, this is gravitational constant mm by r square is equal to mv square by r. This is the centrifugal force and this is the gravitational force. And this capital M is the mass of the gaseous cloud within radius 0 to r. So m is equal to 0 to r 4 pi r prime s square u r prime into dr prime. Okay. And from this equation gmm by r square is equal to mv square by r, we can write m is equal to, this is v square r by g, and v square is equal to, okay, kinetic energy is equal to mv square by 2, so v square is equal to 2k by m, so 2k by m, and denominator is g r. Okay, so now this is mr, this is mr. Okay, so 2k r by, this is g, m small g, and this mr definition is this. So if we take a differentiation dm by dr, I am getting 4 pi r square rho r. Okay, and from this equation I am getting dm dr is equal to 2k by mg. Just equate these two equations. So this equal to 2k by mg, and I have to find out rho r by m. So rho r by m is equal to k by 2 pi r square into g by m square. Okay, from this equation. So option number 1 is correct. Here is a very interesting problem. Here given a gaseous cloud, mass density rho r in free space, and r is the radial distance from its center. The gaseous cloud is made of particles which are moving in a circular orbit, and each particle mass m. So and given that the force acting on the particles is the mutual gravitational force. So the mutual gravitational force balanced by centrifugal force for any particle of mass m as they are moving in a circular orbit. So From this equation, this capital M is the total mass of the spherical cloud within radius 0 to small r. Okay, this capital M is equal to, this is capital M, total mass of the spherical cloud within radius 0 to r. So this is a definition for by r square, r prime square, dr prime to r prime. And from this equation, from equilibrium force I can write this. Okay. So again, kinetic energy of particle mass m given mv square by 2 k is equal to, so v square is equal to this. Okay, I just replace v square is equal to 2k by m here. So mr is equal to 2kr by mg, small mg. So this m definition is m this, so this m definition of this. Okay, so I have to find out rho r. From this I have to get nr. So how to do this? If I derivative this capital M with respect to small r, I am getting a value which is in terms of rho r. I am getting in right hand side something which is in terms of rho r, and my main intention is to find out the rho r. Okay, so for this reason I have to differentiate m with respect to small r. Okay, so from this equation I am getting this, and okay, so this, from this equation I am getting m is equal to v square by small r by g, and v square replace k. So from this equation I have just equate this dm by dr and this dm by dr. Okay, so why have to differentiate this problem, this capital M? Because of, if I differentiate this m with respect to r, I am getting something which is written in terms of rho r, and my target in this problem is to find out rho r. Okay, so I am differentiating this way. So this is rho r, I am getting 4 pi r square rho r, and just matching from this equation 2kr by mg, this dm by dr and this dm by dr, I am just matching this. From this equation I am getting rho r is equal to this, and I have to find eta r is equal to rho r by m. This is from equation number 1. So what is the main thing here? The main thing is I have to just balance this gravitational attraction force is equal to centrifugal force of the particle of mass m, and just replace kinetic energy v square with in terms of kinetic energy, and definition of m is given. As my target is to find out rho r, just I have to differentiate this. This is the main goal. Why have I differentiate this? Because of to just find out the rho r. Once I am getting the rho r, just I am matching this dm dr and this dm dr from this equation. From this I am getting rho r, and also nr. Okay, this is an interesting problem which is coming in Jee Advanced. Okay.